Here, problem 44, page 144. We have three objects, M1, M2, and M3. These objects are connected on the table, on a rough table. It means we have mu, the kinetic coefficient, the coefficient of kinetic friction mu equals to 0.35. The objects have masses of m equal to 4 and 1 and 2. The pulleys are frictionless. You know well, it means that the tension of the cord on the right and left sides are equal, okay? So first of all, I have to draw the free body diagrams of each of the objects. Second, I have to calculate the acceleration of the system. And third, we have to calculate the tension of each cord. Okay, let's begin here. So we can write, we have to draw free body diagram of each object. You know, here we have the weight of each object. Here we have M1, M2, M3. Of the tension, we have T up and T down on the pulley, one to the right and one to the left, and one to the left and one to the right. And here we have a tension up and down. Okay, let's write, because the pulley is massless and frictionless, we can write here T1, 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 and T1. We have the same tension because the mass of the pulley equals to O. We can say the tension at the left and right side, we have the same tension, and the same for the second cord. We have T2, T2, and T2, because the mass of the pulley equals to 0 and also frictionless. Okay. Okay, here we have M1G, M2G, M3G. What we have also, we have the reaction of the table on the block 1, here N, and we have the friction, between the interaction between the block and the table. You know that here we have one mass on the table and two masses to the left and to the right. The right one, we have 2 kilograms, and to the left one, we have 4 kilograms. So the system moves to the left anti-clockwise, okay? So in this case, the system must move in this direction. The left one moves down, the right one moves up. This one is the positive direction of each one. Okay. The motion is to the left, so the interaction between the block and the table must be to the right, opposite to the motion. So here we have F kinetic. I think it's all. We cannot, we don't have a reaction for the object M1 and M3 because these objects don't touch the ground. Okay, the reaction is only for M2. 2. B, I want to calculate the acceleration of each one. You know that to find the acceleration, before the calculation, we talked about this before. This kind of problems must be calculated in the same way. First of all, you have to apply Newton's law for each object. You will get finally many equations with many unknowns, and you can calculate the unknowns easily. So here, to calculate A and also you can calculate the tension by using these equations. So first of all, we have to say 1, we have a inextensible chord. In this way, we can say A1 equals to A2 equals to A3 equal to A. And the same for V. We have the same V. V1 equals to V2 equals to V. Okay, we apply Newton's law on the object M1. You know the positive is down. So the summation of F, we have M1G, the tension T1. I'm talking about M1, okay? Be careful. I take this system only. We have M1G, we have T1 equals to M1A. A takes the same direction with a velocity like this. A, and A. Okay, so A here is positive. We can say here M1. We have only one dimension, so M1 is positive, M1G is positive, T1 is opposite, so it's negative, minus. Oops. Minus T1 equals to M1A. Okay, this is the first equation. Now we apply Newton's law on the mass 2. What we have here, we have N applied on the object. We have T1 to the left, T2 to the right, and we have M2G down equals to M2A. Okay, we do the projection on X and Y. We write I components here plus J components here equals to A. This is a positive direction of A. So we don't have AY, A equal AX. Okay, so we have to write M2 A, we can say A I plus 0 J. Okay, what we have in I direction? We have T1 in the positive direction. So T1, T2 in the negative direction. So minus T2. And we have F kinetic in the negative direction. So minus F kinetic. In function of Y, we have N positive and M2G negative. So N minus M2G. Okay, we take I components and I components. We get T1 minus T2 minus Fk equal mu N. Okay, mu N kinetic equals to M2A. Okay, now it's better to calculate N. You have to calculate N by the projection on G, along G. So N minus M2G equals to 0. So N equals to M2G. We can write the final equation. We have T1 minus T2 minus mu kinetic N. We can substitute the value of N here. We get N M2G equals to M2A. Okay, this is the second equation here. For the third equation, we apply Newton's law on M3. What we have T2 plus M3G equals to M3A. T2 in the positive direction, so T2. We don't need to write I and J here because we have just one dimension. We don't have any force in the X direction. But in the case of M2, we have you have in the X and Y direction. We need to write I and J. So T2 M3G in the negative direction. So minus M3G equal M3A. This is the third equation. As you see here, the first one, okay, 3. Let's write equation 1, this one. We can say M1G minus T1 equals to M1A, and the second equation T1 minus T2 minus equals to, okay, I want to write the second equation like this. the third equation, T2 equals to M3A, just to simplify the calculation, M3A plus M3G. Okay, this one is the first equation. The third equation. Okay, equation 1, this one, we can write T1 equals to, excuse me, the third equation, T2 equals to M3A plus G. It's okay. Equation 1, T1 equals to M1G minus M1A. Okay, this one. This is the second equation of T2. And the second equation here, this one, we have T1 minus T2 equals to M2 A plus mu k times G. Okay, T1 minus T2 equals to M2 A plus mu k times G. Okay, these are three equations. What we have to do, we substitute the value of T1 here, the value of T2 here, and we can calculate A. Okay, it's easy. Let's clean. So we have to put equation 3 and 1 into equation 2. Okay, this one and this one is the equation 2. We have T1 equals to, first one equal to M1G minus M1A, this T1, minus T2 equals to M3A plus M3G equals to M. Here we have M3, M2, M2A, M2A plus M2 rho K times G. Okay? Okay. We take A common, we get, we put A on this side, we get M1G, minus M3G. We have this one, we have this one, and here we have minus M2 times mu k G. Okay, what we have down, we have M1 plus M2 plus M3. Okay, we have the value of M1 and G, M2 we have the value of mu, and we can calculate easily the value of A will be equal to, here we get the value of A equals to 2.3 m per second square. As you see, A is positive, so we choose the right direction. Here you can see if we had the right direction, or we get the opposite. A is positive, so M1 will move down, M2 will move to the left, and M3 moves up. Okay, if you get here A equals to minus 2.3, it means we keep the same values of A and T, but you know the motion must be opposite. In this case, I ask you to calculate the direction of motion. So M1 moves down, down, down. M2 moves to the left, and M3 moves up. Okay, upward. Okay, now I want to calculate the tension. To calculate that tension, we can substitute the value of A in the equation 1 and equation 3 to calculate T1 and T2. So we can, part C, we have to calculate T1 and T2. We can substitute, we can take equation 1. We have T1 equals to M1G. M1 equals to 4 times G minus M1 times A. A equals to 2.3. We get T1 equals 30. We have T1 for the up between M1 and M2, okay? So T1 equals to 30. We can use equation 3 to calculate T2. T2 equals to M3, which is equal to 2 times A equal 2.3 plus 2 times G equals to 10. We get here 4.6 plus 20, we get 24. Okay. We get the final equation, the final value of T equals to 24.2 Newton. Okay, this is a solution. And in general, to resume, you have to apply Newton's law on each object. You calculate 3 equations with 3 unknowns. You substitute T1 and T2. You have one equation for T1, you have one equation for T2, And we have the third one is the relation between T1 and T2. To calculate A, you have to substitute T1 and T2 in the equation, the second equation. You can calculate A, and after you can calculate T1 and T2 by using any one of the equation 1 and 3.